Pro, and it's the client described it as a no display, but it's actually a no backlight. So I'm trying to clean it off. I'm trying to clean off the screen because it might be very difficult for you guys to see the image at the background. I'm not sure you guys can see that, but there's an image here. I'm not sure. Can you pick that up? Yeah. You can, yeah. And even if you try to increase it, you don't get nothing. But there is an image there. I'm not sure there. I don't know. Can you see that?
Yeah, but it's far. But yes, I can see from the bottom
And
there's
that?
something written.
No, on the top there.
Yeah,
And now?
yeah.
No, you can. Okay, so this is definitely a backlight issue and not a no display as the client has described it. So there are two possibilities here. Behind door number one, it could be that this is a screen issue. I'm just trying to clean it so that you guys may be able to spot it out. So behind door number one, this could be an issue with the screen. Behind door number two, this can be an issue with the board. So the first thing we want to do is we want to take and the board out. I see the screws are already out. So, by the way, this is coming from another repair company. So, I suppose they have already done some work on it. So, I'm not sure what we are going to find. We do not have back screws. Yeah, yeah. Like I said, so it's a liquid damage device, and there's been some work done on it. And here you can see, I don't know if this is flux or a remnant from the damage. But yeah, this is yeah. So this is a liquid damage device, and we can clearly see we have issues around the backlight circuitry. It also okay. Not just that. It seems somebody did try to work around the backlight circuitry here. It also seems like yeah, the backlight driver itself was also I believe they replaced it, but that did not solve the problem apparently. Okay, so first thing first, let us see what do we have. So when you are working on a board, your guide should be your multimeter. I mean, the actions that you take has to be dependent on the state the device is in. There has to be a why to every action you take. You don't. So there is that part of you see and then you do. There is that part, but there's also a part to understand the reason behind what you're doing. So I'm not. So I can clearly see that they did try to replace the backend driver and but I'm not sure if the state of the device was defined, because if that is done, that will be a proper guide as to tell you where you are and where you need to be. In any case, let us see. The first thing we want to do is we want to connect charger to the device, and then we want to see what we have on our backlight circuitry. So this is a MacBook Pro, and then our board number. By the way, this is the 16 inches that I'm working on. I'm just waiting on the SSDs. So this SSDs needs to be replaced. I'm waiting for the SSDs to replace, and that will be yeah, that will be all for this one. So and also obviously I need to also address the 2.5 volt circuitry, and that was already taken off before the board the machine got here. So yeah, so I'm just waiting for the SSDs to be delivered. I'm actually gonna get the SSDs from a whole board. So I'm waiting for the donor board. Once I get that, I will prepare the SSDs and then transfer them here, and then I should have a working 16 inches. Now that said, this is an M1 board, and then our board number is going to be you know what the board number is for M1. It is a dash. So there are two M1s board. One is yeah. So one is 080 dash 0 2016, and then one is 80 dash 0 2020 020. So it's 02020, which is pro between them.
2020. That's pro.
Yeah. So 2016, that's our A. Okay, so let's go to let's see 20. Yeah, that is our pro, and then this is our that's our pro, and then yes, indeed you're correct. The other one it's the A. Okay, so let's flip the board. The first thing we want to do for backlight issues, obviously, this is not going to be a case of a fuse. Definitely, this is not going to be a case of a fuse. But again, now the first thing we are going to do, it will also encompass checking up on the fuse, because what we are going to do now is we want to see what we have on our backlight output. That's where we want to start. So let's see what we have on our backlight output first. Our device, I believe, is still on. We can confirm that by confirming what we have on our PP bus line using this fuse here. Yes, 12.45. And then, by the way, 12.45, that is because our battery is connected. If our battery was not connected, you should have something about a little 12 point something, which is way lower than the battery. So I just disconnected the battery in order for you guys to, in order for me to basically tell you guys what I'm talking about. So now 12.32 would mean that you're having 5 volt on, or would mean that your device, that is when the battery is not connected. However, when the battery is connected, you should have 12.0, and that is what am I saying? So without the battery, and with charger only, your PP bus, when the device is starting, you will have 12.0, 12.0, 12 point few numbers, but 12 point less than less than 345. That's what you have. That tells you that your PP bus is okay. However, if you have 12.32, for example, without the battery connected, it means that you do not have a working PP bus line, because in that state, it means that you're most likely having 5 volt on your PPDC in line. Now, when the battery is connected, that is a different issue. As we just saw now, we got 12.40 something. That is because you have a battery connected. So what I have done is I have the battery disconnected. Now, when we check, we should have 12.0 something. No longer, as you guys can see, we are 12.01. No longer 12.40 something, which we just had. So when you have that, it tells you that you have booting voltage on your PV bus. The next thing we want to do is, let me just see. We definitely do have. Don't worry about the fan over spinning. Okay, so that is it. That is the picture profile for the account. I'm not sure if you guys can see that. Can you see that? That's the profile picture. Okay, so now let us see what we have. Let's start from there. We want to see what we have on our um, backlight output, and then we will be utilizing these capacitors here. As you guys can see, the capacitors are on the same line, so we're going to utilize any of these ones. So our black probe on ground, and then our red probe. Let's see, and then I also will not worry if I bridge them in my measurements, because they're all on the same line. So I do this. Let's see, what do I have? I have 0 volt on that side, and that is, I see, and that is the side of that is where the voltage is. So the next thing I'm going to do is I'm going to disconnect my charger and then see if I have a short on that line. Now, I can, two ways I can confirm that. I can do that in continuity mode. By the way, there's this video I was watching, and then I pointed at that sign, the continuity mode, and the camera didn't pick it up. So there was no way. So yeah, so continue. I can do that in either continuity mode, or I can do that in diode mode. So either ways, I can either continuity mode or diode mode. So as initial, I'll do it in a few minutes. So what I'm going to do is in diode mode, I want to see. So if you happen to, if it's if you are using continuity mode, I mean, the way you place them will vary from the way you will place your probes if you switch to diode mode. In diode mode, the red goes to ground, and then the black now goes does the measurement for you. And in continuity mode, it doesn't really matter which is which. You understand? But in diode mode, this is how you do it. So black probe to, red probe to ground, and then black probe to obviously start from ground. Now what do we have? Definitely that is 0. And then on the other side, what do we have? We have 1.249, and in 1.249 it's okay. It means we do not have a short. Okay, now the other thing we didn't confirm is the fuse. Now let us see if we do have a voltage on the fuse. So the first thing we needed to confirm was to be sure that we do not have a short on our backlight output. And then a major reason for that is also because of the way the caps are looking. They're not looking so good. So the next thing we want to do is we want to see what we have on our fuse. let's see, do we have voltage in our fuse? Yes, we do. So our problem is definitely not, we have voltage in and out of our fuse, but what we can see that we do not have is we do not have backlight output. So now before we continue, let us see that we have the voltage line to the screen. So what I mean by that is the two main voltage line to the screen, which is going to be the 5 volt line and the 3 volt line. So what I mean by that, if we switch to the other side of the board, so the screen connector is going to be JP600. Now, when I click on JP600, you will see that there are main power lines for JP600, which are important to the screen being powered. Now, one is PP3V3, which is 3.3 volt, and then the other one is going to be 5 volt. So these two, first we want to confirm that these two are present, because for the newer machines, if either of this is not present, you may not have backlight. So let us see if those are present, and then we can measure on the other side of the board, which is this section here and then this section here. So one is going to be for 3 volt and the other one is going to be for 5 volt. So we can confirm. See, let's see if we have that there. Yeah, 5 volt here, 3, and then let's see, and then this one. Let's see the other one. We should get, yes. So we get 3 volt this side, and then here we get 5 volt. So let's quickly see if our 3 volt is present. So that is going to be here. Okay, so we have 3 volt. That is fine. And then let's see if we have 5 volt. Let's see if we have the 5 volt line. Okay, so our screen DC jack just got disconnected. Let's try that again. And this time we can as well connect the battery, just in case the cable get disconnected. We won't have to start over again. And by the way, you should also see that one of the reason why the fan was going crazy, because of the battery not being present. So when the battery is present, that should balance out the fan being crazy. Okay, so let's see. Can you just confirm that our machine is starting? Yes, our machine is started. And then also, as we can see, that our fan is now stable because we have battery connected. So that is just one thing to note for newer devices. The battery not being present may cause your fan to go wild. Okay, so we have confirmed that our 5 volt line is present. Let's now confirm that our 3 volt line, no, we confirmed 3. Now let's confirm 5. We can use CP712, which is a cap, which is this guy here. Let's see, do we have a 5 volt line? And yes, we do have a 5 volt line. So with everything that, so we can now confirm that the only two things that are going to remain is to check the section that we can clearly see that there was liquid damage, and we can clearly see that there's been previous work done here. And then the second thing is for us to confirm that the what is it called? The screen itself is fine. So what we want to do is we are going to basically install another board here, just to confirm that indeed we have a working screen. While I am pretty sure that this is going to be more of a board issue than a screen issue, because this is coming from another repair company and they must have tested the screen to confirm. And also we can clearly see that we have liquid damage by the section of our backlight. And yeah, so I'm more drawn to the idea that this is going to be a board issue other than a screen issue. But you never know. It is false until you can confirm exactly what state your device is in. So what you're going to do is we're going to put in another board and see if that works, and then we take it up from there. You can just attend to I'll attend to Hassan first, and then we continue. Okay, so what we want to do is put in another board on the show, just to confirm that our screen is working. But like I said, I am very much, I'm more drawn to having an issue with the board compared to having to be an issue with the screen. But like I said, also, you need to be sure, you need to have your facts in place. So let's install another board in the shell to see if we have a working backlight on a different board. We are going to connect only minimal cables, the cables that we need just to get that we have a backlight on our screen. So we're going to connect the screen cable, the DC jack cable, and that's pretty much what we need. So just this and that. So let's see. All we're interested, all we're interested in is just to see that we do have a working screen. And as you guys can see, that is a working screen. I don't know if you guys saw that. Yeah, it's a working screen. So definitely it's not a screen issue. Okay, so now let's now go back to our board. So we are also going to be using this board here as a reference point because this is a working board. We are going to see what is it that they have done so far, and we will then work our way. By the way, for testing purposes, you can use a MacBook Air M1 screen as well as a MacBook Pro M1 screen. So for testing purposes, you can switch between the M1 Air and an M1 Pro. However, you cannot use um, an Intel screen to do the test. So only okay, let's see. Okay. Okay. So let us see what has been done, and then let's see what we need to do. So this is the board that has issue with the backlight, and then on the other side of the board, really nothing much to worry about. Screen cable looks super fine. And now here, so clearly this has been taken out. Let's just compare a working board to this and see what component is missing. So this is the backlight chip itself that is present. The resistor for some reason was taken out. We have a pad here that seem to be, we'll check if that is present. We'll see what that pad is. Here, so we have an empty space here. What is that? Is that okay? That's supposed to be, there's supposed to be an empty space there. And then we have a funny looking resistors due to liquid, and also that. Okay, so first thing first, let's measure. Let us use diode mode to see the difference between the backlight output here and the backlight output here. Yes, we have confirmed that. I'm just gonna confirm again. Backlight output on the working board we have 1.2, and then backlight output here, what do we have? 1.2. Now let's see what we have on this diode here. Here we have 0.922, and then on the other side we have 1.2. Yeah, 1.2. Let's check this one. 0. Yeah, that's almost about the same thing. That is fine. Let's put this on the side. Okay. Um, okay, and then let us see what this measure here, this diode here. That is for keyboard. Now we shouldn't really worry about that. That's a keyboard backlight, so we shouldn't really worry about that. However, we need to worry about it. So now what we need to do, it's easier to, so we need to get a screen to connect to connect it to, so that we can make measurements as we are working along. But before we do that, we can clearly see that the chip itself is not properly, it's not sitting the way it should. let's start by replacing the chip itself, and then yeah, and then we get a screen to connect, but the screen needs to be out. Uh, we need the screen to be out. So let me. Okay, so first and first, let me replace that. And also, I'm also going to be replacing the caps that are not looking so good. Although they are not a problem now, they may become in future. Waiting for the machine to get hot. Okay, it's hot now. Okay, that's out. Also, the resistors here are not looking so good. Let's also replace those. Also, that doesn't look. Yeah, that you see, you guys saw that. That's yeah, the pad of that was completely off. Okay, so the next thing we want to do is clean that section, apply. Uh, okay, let's do this because we don't want this to stop. Yeah, let's say we can't help that. So first and first, let's clean that section of the board. Uh, the pad of this resistor here was completely off. We are going to check what that pad is. Maybe that may just be our problem. Let's switch it, like turn the board in a way that you guys will see what we're talking about. So is it this resistor? Yeah, that one. Because yeah, that one. It should be that one. Yeah, this one here. Yeah, is that one? Yeah. So that is nah, that's keyboard backlight. Okay, nah, that's keyboard backlight. So nah, it's but wait, it's keyboard backlight, but that's a 5 volt. That is a 5 volt line. Yeah, so it just doesn't serve the keyboard backlight. What does it serve? Nah, let's see. No. So yes, if you have 5 volt into it, um, and then the output of that only goes, yeah, yes, no, it definitely goes to UP800, which is a backlight driver. Yes, that is important. It is definitely important. That's a 5 volt line to UP800. And so let us go to the schematic. UP800 is going to be um, um, it's 2020, where are you? 2020, there you go. So what is the name of that chip again? UP800? Okay, so UP800. Now, UP800 is obviously our backlight controller. So here it says band IC display slash keyboard backlight boost converter. That is what it is. Um, let's see. What are we looking at? 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 So, okay. So pin 8 of that chip is going to be, now is that pin 8? Let's see. It's is it pin 8? 5 oh, no, pin 18. Okay, let's see. Pin 18. Pin 18 is going to be, where's our pin 18? 17. I don't see 18. 11, 9, 10. 1, 5, 11, 9, 10, 19, 17, 12, 15, 16. I don't see 18. 1, 2, 21, 4, 20, 13, 14, 6, and 8. I don't see 18. Here we have 25, 22, 3, 7, 23, 24, 16, 15, 12, 17. So where is 18? Hmm. Mm, 1, 2, 21, 4, 20, 13, 14, 16, 6, 8, 25, 22, 3, 7. How come I don't see 18? UP800. Yeah, this is it. This is a backlight driver. But I don't see 18. Oh, am I having problem with my eyes maybe? This is pin 1, yeah? Pin 5. 11, 9, 10, 19, 17, 12, 15, 16. And then 24, 23, 7, 3, 2, 25, 8, 6, 14, 13, 24, 21, 1, and 2. Okay, anyway, we don't see pin 18. Maybe we'll see it later. But nonetheless, we see clearly here that pin 18 is important. I mean, that resistor is important because that is a 5-volt line to the chip. Now, other than that, does that chip have any other 5-volt line? So let's see here. So that's a switch, ground, LCD backlight FET, 5-volt keyboard, keyboard switch, V out for keyboard, current sensing, backlight shutdown. Okay, while there's a backlight shutdown signal. PWM, that's a keyboard brightness, keyboard, SCL data, clock and data, and then enable signal, the 5-volt line. We only have one 5-volt line, and as we can see, and then we have the backlight sense out, and then the backlight feedback. Now we only have one backlight. We only have one 5-volt line, 18, and that it's definitely. But then it just, we see that is a 5-volt backlight. Yeah, that's, yeah, but yeah, 5-volt for two. Yeah, yes, that's 5-volt. There's only one 5-volt, only one 5-volt line to it, and then for some reason we do not see 18 on our schematic, but that is beside the point. That's fine. Let's work on. So clearly that resistor is important. So what we are now going to do is we are going to put back our components, and then most likely we should have a working backlight. Okay. And then another hint I would point to, whenever you are working on a liquid damage device, even some of those components that look okay at the top, the pads may not be okay. So yeah, just save yourself the trouble, and just because that resistor we took out here, it was looking okay at the top. I mean, it wasn't looking, especially resistors, capacitors. You may see that, okay, yeah, this is definitely, but resistors given that is all black at the top, you may not really know that the pad has issues. So you may just let it go, and then you will obviously have issues because the required voltage or the required signal it's missing because of that resistor. So that's something to also keep in mind. Okay, let's grab a donor board and do the transfer. سبحان الله عدد ما خلق من شيء. Okay, we have by the way, the backlight driver that it uses is not universal. So you can also grab the backlight driver from a non M1 board. The backlight drivers are the same. So if you do not have an M1 board, you can get the backlight driver from an Intel board. The drivers are the same. Okay, so that said, and then yeah, let's now replace the missing components. Just waiting for it to get hot. Okay. And then the backlight driver itself. So we need to connect the other, so the other odd air. Otherwise, this takes too much time. Although it's very safe for a board, it's very safe for a board, but sometimes I don't have the patience to wait for it. Okay, now it's time to do the transfer. Then the last is the chip itself. Okay, let's making sure that the chip is properly installed. Okay, now let's remove the excess solder that we have. Okay, okay, so we are going to clean the board, but first and first, let us test our board, test us to see if we now have backlight. Let's hope we do. And yeah, and then afterwards, we can clean the board. سبحان الله عدد ما خلق من شيء. We are going to be connecting minimal cables. We do not need all of the cables to see if we have a backlight on our screen. So we are going to be connecting minimal cables. But just because we need, just because we need to make certain measurements, we are going to have the fan also connected. Because we will obviously be needing the machine to run for some time because we need to make measurements on our backlight output. Okay, so and then the time we took to also install the board in the casing also gave us that room for the board to at least cool off. Okay, then now let's see what we have now. Is our board starting? Can confirm we do not hear the chime. That's fine. Let's see what we have on our PP bus. We can use the fuse. If we get 12.01, then that means Okay, our board is definitely starting. And then also, yeah, that's expected because our battery is not connected. Now, the next thing we want to see is, let's see if our screen is still detected. Do you have 3 point? Yeah, that's fine. And then our 5-volt line. Yeah, that is fine. Now, let's see, what do we have on our backlight output? That is a beautiful backlight. Okay, so let's switch 200 volt and let's see. 43, that is a beautiful backlight. So here we see that where is our backlight output line? Yeah, so this is our backlight output line. So the backlight output line says what? It should say 50 volts. Show me the 50 volts. Show me here. Says 50 volt. That is basically um, at max. No, actually, so it's 55 volts. So at max, that is so you're getting this is a 55 volt, this 55 volt line. But so I'm guessing when the screen is at max, you should be having about 50 volt. When the screen is set to max brightness, you should be having about 50 volt. Here you say it's 55 volt. I have not confirmed that when the screen is at max, you get 55 volt, especially on the newer designs, the M1s and the M1s. But the Intel designs, when the screen is at max, you get about 50 volt brightness. So obviously, now with 43, that is definitely telling us that now we are having backlight on our screen. I don't know if you guys, that's 43.4. That is a beautiful backlight. I'm just going to flip it over, and that is it. As you guys can see, before that was a picture that I was trying to show us that, oh, here's a picture here. But as you guys can see, we have a beautiful working device. And yeah, so thank you guys for watching this. Oh yeah, I was actually wondering why is our touch bar not connected, but because the cables are not connected. And also the reason why the fan is going crazy is because we do not have the battery connected. So the next thing we are going to do is to clean off the board, and Peter will take care of the rest. Thank you guys. I will see you guys in the next one.